What if I told you your brain doesn't have one mind, but thousands? In this video, we'll uncover a groundbreaking theory that could change how you think about intelligence forever. If you're curious about how your brain really works, and how this could shape the future of AI, make sure to watch till the end. And don't forget to subscribe to the book Capsule for powerful book summaries that expand your mind. In the architecture of the mind, every cortical column is writing its own story of the world. Jeff Hawkins, AThousandBrains, a new theory of intelligence by Jeff Hawkins is a groundbreaking exploration of how the neocortex creates models of the world through thousands of parallel learning units called cortical columns. Building on decades of neuroscience and the author's hierarchical temporal memory framework, Hawkins proposes that intelligence arises not from a single unified model but from the collective voting of many independent models, each mapping features in reference frames. This theory reshapes our understanding of human cognition, offers a roadmap for more brain-like AI, and illuminates how perception, memory, and planning emerge from the same underlying principles. Keycap 1 Intelligence as Prediction and Model Building. Hawkins shows that the core function of the neocortex is to predict sensory input by building internal models. When predictions match reality, we experience understanding. Mismatches drive learning. Actionable strategy. In daily tasks, like navigating a new route, pause to predict what you'll encounter next, then compare your prediction to reality, sharpening your brain's model-building skills. Keycap 2 Cortical columns as independent learners. Each cortical column learns a complete model of objects or concepts within its sensory domain. Intelligence emerges from their collective consensus. Practical example: instead of relying on one source, gather multiple viewpoints when making decisions. Strategy: break complex problems into smaller components and seek independent solutions, then integrate them for a robust outcome. Keycap 3 Reference frames unify sensory inputs. Columns use reference frames, location-based coordinate systems, to link sensations, touch, vision, sound, into coherent object representations. Actionable tip: when learning new information, anchor it to multiple contexts, visual, spatial, emotional, to create richer mental reference frames that improve recall. Keycap 4 Sensoromotor integration drives understanding. Hawkins emphasizes that movement and sensation are inseparable. We learn objects by touching and moving around them. Strategy: adopt embodied learning techniques, use gestures, build physical models, or walk while brainstorming, to engage your sensoromotor system and deepen comprehension. Keycap 5 Sequence memory underlies prediction. Temporal sequences, like the steps in a process, are stored by columns as transitions between states. This sequence memory enables anticipation of what comes next. Actionable exercise: when mastering a new procedure, break it into small, repeatable steps and practice them in order, reinforcing your brain's sequence learning mechanisms. Keycap 6 Attention as selection of reference frames. Attention focuses processing on particular columns and reference frames, enhancing prediction accuracy. Practical tip: use focused attention sprints. Set a timer for 15 minutes of uninterrupted work on one task, minimizing distractions to strengthen your brain's attentional networks. Keycap 7 Continuous learning. Never freezing the network. Unlike many AI systems, the brain never stops learning. Hawkins argues for architectures that learn continually without catastrophic forgetting. Strategy: Incorporate spaced repetition into your study routines and review material at increasing intervals to mirror the brain's continuous learning process. Keycap 8 Ensemble Decision-Making from Model Consensus. Columns vote on the most likely interpretation of sensory input, and the consensus becomes perception. Actionable strategy. When faced with a tough choice, solicit opinions from a diverse group, each person acting like a column, and make decisions based on the collective input rather than a single viewpoint. Keycap 9 Implications for AI. Toward brain-like architectures, Hawkins critiques deep learning's limitations and advocates for hierarchical temporal memory, HTM, as a more biologically plausible alternative. Practical step. Explore open-source HTM frameworks, such as Nementa's, to experiment with brain-inspired AI models and stay abreast of emerging architectures. Keycap 10 The Promise of Understanding Consciousness. By revealing how the neocortex builds multiple models and integrates them, Hawkins offers a path to demystify consciousness and develop machines that truly understand. Actionable idea. Follow the latest research in neuroscience and cognitive science, subscribe to journals or attend webinars, to track progress toward mapping the brain's unified theory of intelligence. So, that was AThousandBrains, a fascinating journey into how our mind truly works. I hope this summary gave you new insights into intelligence, learning, and the incredible power of your brain. Let me know in the comments. What part blew your mind the most? If you enjoyed this video, don't forget to like, comment, and share it with fellow knowledge seekers. And of course, subscribe to the book Capsule and hit the bell icon so you don't miss the next powerful book summary. Until then, keep learning, keep growing. See you in the next video.